Good evening, ladies and gentlemen. In this video I shall be looking at other similar identities to sine of arc cos x equivalent to square root of 1 minus x squared. The maths here will use some higher level stuff than previously, essentially a whole load of algebra. Okay, let's get started. So in the previous video I showed how you got x, y, r equals 1 and theta, and you could use some trigonometry, so sine, cos, and then get theta as an expression of x, and then get y as an expression of theta, and y as an expression of x. But then also using Pythagoras, so you have x squared plus y squared is 1. Just rearrange that to get y squared on the left hand side and 1 minus x squared on the right hand side, and square root of course, and you have two equivalent y's. And there you have sine of arc cos x is equivalent to square root of 1 minus x squared. So we can try this again, but instead of taking arc cos of x, we can take arc sine of y. And so we want x as a function of y, so x equals cos theta, which is arc sine y. Boom, x equals cos of arc sine y. And again, Pythagoras, x squared plus y squared is 1, x squared is 1 minus y squared, x squared is the square root of 1 minus y squared. Therefore, cos arc sine y is equivalent to square root of 1 minus y squared. So if we get sine of arc cos x is equivalent to the square root of 1 minus x squared, and then what we've just learnt is cos arc sine y is equivalent to the square root of 1 minus y squared. And we need to remember that this is just sine of arc cos of some number is equivalent to the square root of 1 minus that number squared. And we can just replace these to sort of help clear our minds a bit with an a, for example. If we take the traditional mathematical function notation, we get y equals f of x, and then to inverse that we have x equals f to the minus 1 of y, or x equals inverse of f of y. And to put that algebraically, we can substitute f of x with sine of arc cos x, and y equals sine of arc cos x. Then you can take arc sine of both sides, so arc sine y equals arc cos of x, and then cos of both sides, cos arc sine y equals x, and therefore f inverse of x is cos of arc sine x. So that means this is the inverse of that one, but we also happen to know they're identical. Therefore sine of arc cos a is its own inverse, as is square root of 1 minus x squared. And of course you can see how that works by looking at the graph. It's just a circle, and to take the inverse visually you reflect it along the line y equals x, and of course the circle does that. It's the same when you reflect it. In order to find other trigonometric and algebraic relations, we go back to this triangle, and here we have x, y, radius of 1 and theta again. So let's just write those down. We have sine theta, we have cos theta, and of course tan theta, which we didn't use previously. So this time we want theta in terms of tan, so if we take arc tan of both sides, we have theta equals arc tan of y over x, and then with that we get x equals cos theta, x equals cos of arc tan y over x. Now before we had x as a function of y, or y as a function of x, but now we have x as a function of y and x. To simplify things, we can let a equal y over x, therefore x equals cos arc tan of a. To find the other side of the identity, to find the other expression, we can go back to Pythagoras, so x squared plus y squared equals 1, and then we recall that a is y over x. We have x squared and y squared, but we want x squared and something with a in it. To get y on its own, we multiply by x, y equals a times x, and x squared plus y squared equals 1, or x squared plus a times x, brackets squared equals 1, and that's just x squared plus a squared x squared equals 1. And then we can factorise there in terms of x, and then bring that over to the other side, so x squared equals 1 over 1 plus a squared. Square root that, x is 1 over the square root of 1 plus a squared. Now we also know x is cos arc tan a, so that means cos of arc tan a is equivalent to 1 over 1 plus a squared. So we could do more things like that, but instead let's take some of our old ones. So let's go with cos of arc sine x is equivalent to the square root of 1 minus x squared. And now we can divide that by sine of arc sine x. That is, of course, just x, bearing in mind that arc sine x limits the range, and therefore this is only equivalent from -1 to +1. But cos of something divided by sine of something is cot of something, or I suppose 1 over tan of something. So cot arc sine x is equivalent to the square root of 1 minus x squared over x. And of course, just take the reciprocal of both sides and boom! Tan of arc sine x is equivalent to x over the square root of 1 minus x squared. Delicious. So, even more of that. Let's take from the previous slide, tan of arc sine x is equivalent to x over the square root of 1 minus x squared, and then manipulate that one. So if we take some variable to equal that, let's say y equals tan of arc sine x, then of course y equals x over the square root of 1 minus x squared. Once again, we can generate a new identity by taking the inverse of these functions here. So if you take the inverse of this and the inverse of that, then those two inverses will be equivalent. Let's start on the left. Take arctan of both sides, arctan y equals arc sine x, then sine of both sides, so x equals sine of arctan y. Fairly simple. And then this one, we want to square both sides, and then we want to multiply by 1 minus x squared, so it'll be y brackets 1 minus x squared, or if you expand that, y minus y squared x squared equals just this x squared here. And then you want to carry the y squared x squared over to the other side. Now that we've got it here, we can factorise. With our x squared all on its own, we can divide out this 1 plus y squared and square root. And therefore, of course, sine of arctan y is equivalent to y over 1 plus y squared. And then remembering our previous cos of arctan x is equivalent to 1 over the square root of 1 plus x squared, we can apply the same process here, and we'll find something with tan of arc cos in it. So y equals cos of arctan x, y equals 1 over the square root of 1 plus x squared. On the left, if we just take arc cos of both sides, then tan of both sides, and we just have our x on its own. And then on the right, we want to square it, multiply 1 plus x squared through, and then here we have no other x squared, so to isolate an x squared we need to first get rid of this y squared, so do 1 minus y squared and just have y squared x squared, and then of course you can just divide through by y squared, and x squared is 1 minus y squared over y squared. Just square root that, and here we have two equivalent x's. Therefore tan of arc cos x is equivalent to the square root of 1 minus x squared, all divided by x.